Welcome back to Alchemy Explains. For the last couple of years, the tech industry has been completely infatuated with a single fantasy, the autonomous AI swarm. The pitch was simple. You gave a cluster of AI agents a high-level goal, step back and let them talk to each other, plan their own steps, call whatever tools they want, and solve complex problems entirely on their own. It looks like magic in a 5-minute conference demo, but if you have tried to ship an unconstrained multi-agent system to production anytime recently, you already know the brutal reality. They break constantly. Today, we're looking past the hype of pure autonomy. We're breaking down why free-roaming agents inevitably collapse under the weight of compounding errors, and why the smartest engineering teams in 2026 are trading autonomous chaos for strict, deterministic orchestration using Directed Acyclic Graphs, or DAGs. Let's start by looking at why standard agentic loops fail the moment they touch real-world infrastructure. When you build a system where an LLM acts as the orchestrator, deciding its own plan, picking its own tools, and deciding when a task is finished, you are trusting a non-deterministic model with deterministic system logic. LLMs are incredible reasoning engines, but they are terrible state managers. If you give an agent the freedom to choose its path, it will eventually encounter an ambiguous error, misinterpret an API response, or trigger an infinite retry loop. Because it lacks hard boundaries, it will try thousands of times, burning through your cloud budget in minutes, or silently passing corrupted data down the pipeline. The more freedom you give an autonomous agent, the lower its overall system reliability becomes. To fix this, elite engineering teams have abandoned the concept of the free-roaming swarm and embraced a foundational computer science concept, the Directed Acyclic Graph. A DAG is a data structure composed of nodes and directed edges, where work flows strictly in one direction, with zero cycles or loops allowed back on itself. When applied to artificial intelligence, a DAG completely flips the script on how agents operate. Instead of letting an LLM act as the boss, the DAG acts as the strict operational framework. The AI is demoted from orchestrator to worker. In a DAG-based workflow, every single step of a business process, whether it's extracting an invoice, validating a user identity, or formatting a database query, is mapped out as a discrete, isolated node. The AI model is plugged into a specific node to perform a specific reasoning task, but it has zero control over what happens next. The execution path is entirely deterministic, controlled by traditional code and state machines. The system can only move from node A to node B if the output of node A passes strict programmatic validation checks, like matching a rigid JSON schema. If the AI hallucinates or produces malformed output, the DAG catches it instantly at the boundary, preventing the error from poisoning the rest of the system. This architecture solves the two biggest killers of production AI: context drift and compounding failure rates. In an unconstrained multi-agent loop, as the conversation history grows longer, the agent suffers from context rot. It starts forgetting the initial security rules or business constraints you specified in the system prompt. By structuring your workflow inside a DAG, you enforce atomic task isolation. Each node receives only the exact context it needs for that single microtask. It doesn't need to remember what happened 3 steps ago, because the state is managed entirely by the underlying graph orchestration layer, not by the model's active memory. Furthermore, DAGs allow teams to gracefully implement human-in-the-loop checkpoints right where they matter most. If a node's confidence score drops below a strict threshold, the DAG automatically pauses execution, routes the state to a human dashboard for review, and resumes only after an explicit sign-off. The system cannot go rogue because the code physically forbids unauthorized lateral moves. We're moving past the Wild West of generative AI. The companies successfully scaling enterprise automation in 2026 are not the ones building the flashiest, most autonomous agents. They're the ones building the most rigorous, disciplined orchestration layers. AI is the engine, but the DAG is the transmission. If you want reliability, stop giving your models total freedom and start building strict, beautiful borders. Are you currently fighting with autonomous agent loops in your own stack, or have you transitioned to state machines and DAGs? Let me know in the comments below. If you want to keep mastering the architecture of the future, hit subscribe, and I'll see you in the next episode.